All right, so hi, good morning, everybody. Thank you for joining us today for our webinar on the new OpenAIRE Graph API. So today we have with us Thanasis Vergoulis from the OpenAIRE Graph team, who will be presenting the new Graph API. And we kindly ask you to please keep your microphones muted during the presentation to avoid any background noise. And at the end, we'll have some dedicated time where we'll give you the floor to ask any questions. So you can, for these questions, you can write all of your questions in the Zoom Q&A. And a reminder that today's session will be recorded and transcribed. So if you do not wish to be recorded, please let us know and we can edit any questions or comments you may pose out of the recording. So with that said, let's get started. I'll pass the floor now over to Thanasis. Thank you.
Hello, everyone. Can you hear me?
Yes.
Okay, great. So just give me a minute to open screen. Okay. Can you see my screen?
Yes.
Okay, great. First of all, let me thank you, everyone, for being interested in this webinar about the new OpenAIRE Graph API. I'm Thanasis Vergoulis, a principal researcher at Athena Research Center, and I was also involved in the design of this new OpenAIRE API in the past few months. So before starting with the main content, I would like to provide an overview of the scope of the today webinar. So today I plan to give you a quick introduction to the OpenAIRE Graph API. We are going to go through some interesting and simple examples, some real world use cases that so that you can get insights about the potential ways that the API can be used. And we are going to also discuss some improvements that are expected to be included in the next version of the OpenAIRE Graph API, version 2, which will be released very soon. Keep in mind that a more detailed API training event is upcoming in the next weeks or months, so stay tuned. But I think that you will also be able to get a good glimpse on the capabilities of the OpenAIRE Graph API, even by by participating in this today webinar. So I will start with the basics. What is the OpenAIRE Graph and um, the APIs? So the OpenAIRE Graph is a very large scientific knowledge graph or a scholarly knowledge graph that incorporates metadata from thousands of sources, of data sources. Many of them are repositories, institutional repositories, thematical repositories. Others are aggregators, open access journals, other types of registries, CRIS systems, etc. But not only this kind of sources, inside the OpenAIRE Graph, we can also find information that comes from some very important data sources, like Open Citations, like Microsoft Academic Graph, ORCID, DataCite, Crossref, and so on. The OpenAIRE team, the OpenAIRE technical team, makes sure to collect metadata from all these sources. clean them, deduplicate them, and this is a very difficult process. And after that, enrich them with additional metadata that can be extracted by the text mining algorithms that the OpenAIRE team is doing on open access publications that are available to produce this large knowledge graph that contains information related to research products like publications, datasets, software, but also other types, and all the relevant or connected actors or other types of entities in the research ecosystem. So you can find connections of those products with particular grants, particular projects, organizations, research performing organizations, for instance, like universities or research centers, and of course, people, researchers, and so on. And this rich knowledge graph is openly available and can be accessed in various ways. It can be accessed using the OpenAIRE Graph API that we are going to describe today. But it is also possible to download and use the open datasets that are being released by the OpenAIRE team. But keep in mind that since we are talking about a resource that contains metadata for hundreds of millions of research products, the respective files are pretty large, and to work with them, the most likely is that you will need a distributed infrastructure. So, of course, apart from these two main ways that the metadata inside the OpenAIRE graph can be useful to the research community, there is always the option to use OpenAIRE services that are built on top of those data and provide useful functionalities to the research community at large, or even third-party services that are consuming data from the graph APIs or the datasets to provide useful value-added services to the research community at large. So, because I mentioned the dataset and the API, a first question that someone may have is when it is more appropriate to use the one instead of the other. So the Open Graph dataset that can be found uploaded on Zenodo is more appropriate for use cases where heavy processing is involved. Like for instance, for cases where complex analytics should be performed on top of the data, or if the data inside the graph should be used to train machine learning models. So for this kind of use cases, it does not make sense to use the API and make consecutive calls, as we will see later on. This will introduce a lot of delays. Then another case where the graph dataset could be preferable is in cases where batch processing is needed. Again, the problem there is the same, that the alternative would be to try to send a multitude of API calls that will introduce significant delays. The Graph API is more appropriate for cases where we need to have always up-to-date data without having the need to copy or move the large graph dataset from the one place to the other. I mean, download it from the Zenodo repository, for instance, to another storage, distributed storage that may be used for the processing. So any time that those files are updated by OpenAIRE, it will be needed to reload the dataset inside the infrastructure that is being used for processing. So especially if not other reasons like those that I mentioned above, are in place, there is this data movement will not be worth it, and it should be avoided. But if you use the Graph API, of course, anytime that the user is performing a query, an API request, the data, the metadata that come back in the response are always the most up-to-date ones. In addition, of course, if someone would like to use the dataset, this would imply that an extremely large storage space will be needed. And if this space is not available, then the API would be the only option. Using the API would be the only option to consume data from this API. And of course, as I already mentioned, the scale of the size of the dataset is making it inevitable to use some distributed computation models. Not everyone has experience with those, like Apache Spark, for instance. So if the end user has no expertise in those technologies, then the API can provide a more convenient way to consume the contents of the OpenAIRE graph. And finally, in a lot of scenarios, the whole graph is not required. Only a small part of it is relevant to the use case. It's like querying a database that you get a small amount of the records. Something similar here in such scenarios that you would like to retrieve a small part of the graph and perform an analysis on this part, then the Graph API would be preferable. And if someone is interested to know more about the Graph API, this is a RESTful API, and the responses it provides are in JSON format, so it is in a JSON native format, the responses of the API. And for those that are curious, the implementation of the API is based on Java, the programming language for implementing the API, and Apache Solr, which is the technology that is used for organizing the metadata in the proper format so that the responses of the API can be retrieved in an efficient way. And of course, there are useful links that I have included here in on this slide. First of all, the base URL of the API. But in addition to that, the documentation web page. This is part of the official documentation of the OpenAIRE graph. There is a particular section inside this documentation page that focuses on the various public APIs that are related to the graph. And the first one that is covered is the Graph API. So if you are interested in anything that I'm going to describe today, you can find all the details in the respective section of the documentation. And if not, please let us know and we will try to guide you, but also to improve the documentation accordingly. Now, for those of you that you have already worked with other APIs, a RESTful API, you know that a RESTful API consists of a series of endpoints. So these are the different functionalities that are provided by the API. On this slide, I have summarized the currently available endpoints of the Graph API. There are two that are covering organizations metadata. The first one is used to search for organizations. You can provide some keywords and then get back all the metadata for organizations that match those keywords. The second one can be used if you already know the OpenAIRE identifier of an organization. You can get the same information for this particular organization that is being identified by the respective identifier. Something similar is also true for the other types of endpoints. For the data sources, we have the same type of endpoints, and for projects as well. For research products, which are the most important entity covered in the graph, you can find those two endpoints, like the others that I described for the organizations. But in addition, there is another one related to the links that are connected to the particular research product. And we will see later on some examples. There are different types of links, different types of relationships that can be connected to a particular research product. Citation links, for instance, but not only those. Links between products and projects or products and organizations are also very interesting. And this endpoint here can be used to provide access to this kind of relationships. Now, before moving into some practical examples so that you can get more insights about how to use the API, I would like to also provide some history, a brief history of this new OpenAIRE Graph API. So before that, the main API that could be used to consume data from the graph was the search API. This is still available, but it is now deprecated, and after a couple of months, if I'm not mistaken, it will be discontinued. So the new OpenAIRE Graph API was created to replace this search API and improve it in various ways. The search API was in use by various third parties and was the basis of various services. But at the same time, the OpenAIRE team was aware that there were some issues that were creating difficulties for developers that were building applications on top of this API. The first important limitation was related to the fact that the search API was an XML native API. The responses were mainly in XML. And although JSON was provided as an option, the respective JSON responses were automatically generated by the XML, and the JSON format that was being produced was very complex, very confusing, not that easy to read, but also not that easy to consume based on some particularities that existed in this JSON, in this transformation between the XML and the JSON. So the Search API, the Graph API implemented the native JSON API. The responses were in JSON, and their structure was created in a way that would be more convenient for programmers to consume the respective responses in their scripts. Also, the previous API was not very well aligned with the data model of the OpenAIRE graph. A lot of the parameters, a lot of the fields were named differently. Even some of the values that were provided in the responses were not completely aligned with the way that the same information was structured inside the open datasets, for instance, creating some confusion to the programmers. So the new Graph API tried to address this problem. In addition, the documentation provided for the Search API was very basic. And the OpenAIRE team tried to improve a lot the documentation to provide a significantly better and more complete documentation for the new Graph API. And some additional functionalities were implemented, like additional or extended endpoints, parameters, and fields, but also some mechanisms like, for instance, the cursors mechanism that allows for browsing the retrieved results page by page in a more efficient way. This work started about a year ago, and in June 2024, we had an internal testing by members of the technical team of OpenAIRE that they tried a very primitive version of the new Graph API, provided some feedback, some ideas for improvements, and things like that. Then in July and August of 2024, we had organized a large campaign about beta testing the new Graph API. We have involved external volunteers, and those volunteers were not people that didn't know about the OpenAIRE data. The majority of them were existing users of the Search API, but of course we also had some people that were not familiar with the previous API. So this mix was very good for us because we had two different kinds of beta testers. The experimentation lasted for more than 1 month. So we gave to those external volunteers access to a beta version of the Search API. We asked them to play with it, and then we had the ticketing mechanism in place to collect bugs and features. And at the end of this period, we also asked them to complete a questionnaire to collect some structured feedback based on the experience that they got. And after that, we have analyzed the feedback from the beta testers, tried to prioritize the requests, and tried to address any bug that they have reported. And the official release of the Graph API version 1 has been done in February 2025. And very soon, if I'm not mistaken, inside May 2025, we are also going to have the version 2 release that will bring some improvements and that it will be also backwards compatible to the API version 1. Now, before going into some examples, I would like to also provide some insights to some people that are not very familiar with how to use an API. The Graph API offers a Swagger UI, a user interface, a web user interface that displays all available endpoints in a visual way, and offers also options for experimenting with the endpoints in place. So it's a very convenient way for beginners to play with the API. You can find this UI in the link that I have included in this slide. And if you go there, open this link in your browser, you can then click on a method that you are interested to test. Press try it out, fill in the parameters, and then execute the request without the need of writing any single line of code. Then we have also the option to use the command line to send the request to the API. More or less, this is the way that I'm going to use for the practical examples that I will display later on. To do this, you should open a terminal or any other shell that you have on your own operating system, and use the curl command, curl command, to make the requests. Here, for instance, I have included an example request. You type curl, -x get is the syntax that determines the type of request in our particular case, and for all of the endpoints that we have for this API, the type of request will be get. It's not that important, so just include it as a parameter. Then we have the user query that consists of the URL, the base URL of the API, followed by the endpoint that we are interested to use. In this particular case, we would like to use the research products endpoint, followed by the parameters. In this case, we have only one, which is the page that we would like to get back. In case we had more than one such parameters, the parameters are divided with the ampersand delimiter. And finally, we have another syntax, another parameter, -age, with which we can set the HTTP headers here. But this can be omitted, and I will omit it in the next examples because the JSON format is the default. And of course, there are other options. There are some desktop apps that you can use, like Postman or Insomnia, that can be used to send REST API requests and manage those requests in an interface that feels like an IDE for a programming language. And also, it is possible to write some Python scripts or some programs in other programming languages to send the requests and then process, analyze the results inside your code to produce some visualizations or aggregations, or in general to perform any formatting that you would like to the results that you get from the API. And of course, this is the case when we are talking about real use cases. If someone would like to use the API to build an added value service on top, then of course what is taking place is development of programs like this that consume the responses of various API calls and produce the desired results. But in the context of this webinar, as I said, I will focus mostly on the CURL, the kernel option. So we are not going to examine any desktop app, or we are not going to build any program. However, maybe the latter task will be part of the upcoming training activity that I mentioned. And the final thing before going to the examples is, as any API, the Graph API offers applies some rate limits. So it is free to use and can be accessed by anyone, even you are not, even if the end user is not authenticated. But there are different rate limits for authenticated users. If you are connected as an authenticated user, then you can query, you can send up to 7,000 requests per hour, while if you are unauthenticated, this limit is to 60 requests per hour. And to make an authenticated request, you must first register, and then you get access to some tokens that can be used for sending the API requests. More information can be found on the documentation page of the Graph API that I have included in the previous slide. Finally, the data have the CC BY license, which means that you can use the API for commercial or non-commercial uses, but you have to acknowledge the use of the OpenAIRE Graph as a data source. And now it's the time that you all expected, I think. The first example that we can try to run. So this is a very simple example, the first one. I will try to fetch the metadata for a research product of interest using the CURL method. The request that I should write is the one displayed here in the red box. I will pause here the presentation, copy this so that you can see that request working in practice. I will open the command line. Let's see here. Okay, I think now it's big enough. I will copy here. I will paste here the request. And as you see, after hitting enter, I got the metadata of the respective publication. Now, you can understand that this is not very convenient. It's not very easy for someone to make sense of all this information. So what you can do in the case here is to copy this string inside an editor that supports JSON format. And then after the first improvement, as you can see, is that different colors are applied to different pieces of information. If something is a name of a field, it gets an olive color here. If it is a value, string value, it gets a purple color, and if it is a number, it gets a magenta color, something like that. But also those editors provide a way to format the document. So I hit the format, and as you can see now, we have a more convenient format. We can even have the option to open and close, expand and collapse different parts of the XML of the JSON document. So you can see here we have an array with the authors. This is a publication of mine. So for instance, I am one of the authors here, and some information for me is provided, like my ORCID number. You can see also some subjects that relate to this publication, the language, if it is available. The main title of the publication, this is the title of the paper that I wrote. In the descriptions, you can find the abstract or the abstracts that would be found, because sometimes you have multiple versions, multiple instances of the same publication grouped together, because they are different versions, like the preprint and the peer-reviewed version. We have the identifier, the OpenAIRE ID, but also the original PIDs here, a DOI, for instance. Some indicators based on citations that we calculate. For instance, you can see here that this paper has already received 2 citations. Here are the different instances. So more or less this type of information can be retrieved. So going back to the presentation, as I said, when you're using CURL, you get this type of information that is not very legible. You can use a JSON formatter based on some program that supports JSON to make it more legible. But of course, this is different if you are using an app. Then it will be possible for you to get the information in the proper format. But also, if you are testing the API using the Swagger interface, you can have a similar experience. Let's see a more interesting example. Let's say that we don't know what we are searching for, or we have a particular, maybe we have a particular publication in mind, but we don't remember its identifier, its PID, its DOI, for instance, or the OpenAIRE ID in this particular case, or maybe also we are just interested in a particular subject and we would like to provide some keywords, and we would like to get some relevant results. So here, this is not correct, not the OpenAIRE graph, the knowledge graph is the example. Okay, so in this particular case, I am interested to get publications, the first 10 publications in particular, that relate to the knowledge graph keywords. And I would like to get the first 10 based on the keyword relevance. So I will give those keywords to Solr. Solr will try to rank all documents that all papers that are inside the index based on the relevance that they have to the given keywords, and then the results that I can retrieve will be those that have the highest relevance score. So to get the highest relevance score, I also need to determine that the ordering of the results should be based on the keyword relevance, but in a descending order. So here, for instance, I have created this API call I have used the research products endpoint, as you can see, with a particular the research products with a particular parameter, the parameter search. If you see inside the documentation page, you will see that this field expects a set of keywords to be provided, and then the system tries to find documents that include these particular keywords. Now you see here a very weird set of characters repeated in various places. So this percentage symbol followed by 20 is encoding the space character. The reason why we don't use here the space character directly is because this is not allowed in raw form in the URLs. So we need to replace it with this particular encoding. Depending on the system that we are using. For instance, if you are using a particular app, as I mentioned, the app may replace the spaces with those characters for you, but here in this particular case, it is needed for me to perform the encoding before sending the request. And so I have asked for the knowledge graph, knowledge space graph, keywords to be present. I also ask with another parameter the type to keep only those research products that are publications. So this will exclude datasets, software, and other types of research products. I ask again the first page, which the default page size of the API is 10. So this will give me back the top 10 publications. And then I ask the system to sort the results based on keyword relevance and in descending order. So I will stop again the presentation here to show you this in practice so that we can get also the results. So I get this query, go back to the terminal, and you can see that we get also that we get again a similar output. If I copy this, in this particular case, we have 10 results, so this is why it is longer. So if I get this and copy inside here, and then hit format document button, you can see that I have retrieved some results, multiple results. Each result is here, an entry here. And if I focus on one of them, you will see that we have the authors, we have a similar type of information for each of them, the main title, as we had for the previous case. Now, if I go to this particular results and examine the citation-based indicator section, you will see, okay, that I get a first publication that has 41 citations related to knowledge graphs. The second one has 12. So there are some citations, but let's say that I would like to get the same result, the result of the same query, but this time sorted by not the relevance, the keyword relevance, but the citation count. If I copy this and go back to the terminal, I get a similar set of results, but this time this result set will be different. because I asked the system to rank the results based on a different criterion. So I'm just trying to copy this so that, oh, let me start from here. Almost there. Okay, here we are. Okay, and if we go again, the top of this new document, and examine for the first result, the indicator section, you will see that this particular publication has more than 30,000 citations. So in this way, we can prioritize, for instance, we can get the most cited publications using the Graph API. Now, this is not the only indicator. The citation counts is not the only citation-based indicator that is provided by the OpenAIRE Graph. There are others, like for instance, popularity, which is a particular type of indicator based on citations that reduces the bias against recently published works because those do not have enough time to collect the same number of citations as the old papers. So popularity is a citation-based indicator that tries to reduce this bias. And there are also some usage-based indicators based on downloads and views. What I don't remember, but this is easy to check, is if you can use these usage-based indicators for ranking as well. I think currently it's not supported, but it is something that very soon it will be possible to be supported. Anyway, all the details can be found on the API documentation page. Something important that I mentioned in the beginning is that one implementation that was very important was the cursor implementation. Traditional pagination, like the one that we used, where we use the page and the page size parameters, has some limitations. It creates performance issues. For instance, it is very difficult as you go from one page to the other. If the page number becomes really large, then it becomes more and more resource heavy to get back the results, calculate the results. And this is also the reason why, not only for the OpenAIRE Graph API, but also for other similar APIs, to provide the hard limit when you are using the traditional pagination. And in the case of the OpenAIRE Graph API, this limit is to 10,000 records. But to overcome this difficulty, not only to be able to get more results than that, but also to get those results that are in the last pages in a more efficient way for cases when you are trying to retrieve subsequent pages of a query, cursor mechanism has been implemented. Now, how this is used, you can use the cursor field here with the asterisk value. so that you initiate the cursor mechanism. You get the first page with that syntax here, and then inside the results, you also get the next cursor as one of the fields that comes inside the retrieved information. And this value, you can use it for the next call. You replace the asterisk with this next cursor value, and this brings you the next page. And so on. The next page will also include the next cursor value for the page after that, and so on. So I think that for the interest of time, it does not make a lot of sense for us to test this in practice right now. You can test it, of course, offline. So I will move to the next example because, it's the same kind of query that we had before. The only thing that changes here is the cursor mechanism that works pretty straightforward, like I mentioned. So let's go to some other examples that may be more interesting. Let's say that we would like to fetch the most cited publication or publications produced by an organization of interest. How we can do this? First of all, we should find the identifier of the organization of interest. So in my case, I'm interested in Athena Research Center, Research and Innovation Center. So I search using the endpoint for organizations and the field search here with the keywords Athena Research and Innovation so that I can get back any organization that matches that. So if I do this, you will see that I will get back some entries, and the first one is this one that has is Athena Research and Innovation Center, that has this identifier. Okay, so getting this identifier, then I can use the research products endpoint with one parameter that is called relevant organization ID, and including the ID that I already found, I get back the results. I get back the most cited publications of this related to this particular organization based on the metadata that I can find inside the OpenAIRE graph. The top 10 ones. So again, doing the same. Let's see how many citations. That's the first one. So the most cited publication of Athena Research Center has more than 1,000 citations. Okay, let me go back to the presentation. We can do something similar for projects. I will not run it right now, just for the interest of time. But in general, we run a query to get back the projects, to get back the identifier of the project. In our case, I'm interested to find publications related to the project GraspOS. And then after I get the identifier, I can use it with the research products endpoint, the parameter relevant project ID. I will get back the top 10 publications, and I can then examine the subjects of those publications that include the fields of science or some other keywords that are related to this particular papers. And of course, okay, if I write a script that consumes those data that I get back from the API request, I can even make some nice visualizations uh, to visualize the most important terms that are related to the publications of this project. For instance, to build the tag cloud, the word cloud. Here I have also an example on how to get citations for a given publication, not the citation number, but the list of citations. This will retrieve all connections that the graph contains about of this particular type, where the relation is sites. Keep in mind that this call will very likely provide you more citations than the number that you will find in the citation-based indicators, because the calculation of those indicators is based on a methodology that is taking into consideration a subset of these citations. Because, for instance, data citations are not included there, but you will find them here.
Sorry, thank you. I just don't mean to interrupt, but we just have a couple minutes left, and I wanted to make sure we got to a couple questions.
Yes. It's not an interruption because the last one slide is here.
Oh, perfect. Perfect. Great, thank you so much. So I see we have a couple questions in the Q&A. I see some were answered in the chat as well. If anybody has something that they would like more elaboration on that was in the chat, please feel free to raise your hand. But we'll go to the ones quickly in the Q&A. So we have first, which I think might have been answered in the chat, but just to be sure. We have from Albin, what is the approximate amount of data that can reasonably be downloaded with the new API? And I think we answered this in the chat, but just to maybe confirm for everybody.
Yes, I mean, I don't know if someone else would like to take that, but in general, based on the cursor mechanism, you can get back all the more or less all the records related to a particular query. If you are using the traditional paging and for performance reasons, as I explained, there is a hard limit that you can get back about the first 10,000 results. Now, in most cases, and when the API is the more appropriate way to be used, this is more than enough. But again, if you need to consume very large amount of information through the API, this may be a sign that you should download and use the open dataset instead.
Great, thanks. The next question was, are there any recipes for using API programmatically to save time?
There is some page, as far as I remember, in the documentation page that provides a very simple example. And if I'm not mistaken, I have included this example here inside the here. This is taken from that place. So I'm not sure if there is any other guidance regarding that, but I'm sure that maybe in a later training event, this also could be something to consider. But yes, inside the documentation place, you will find a very simple example explaining which is the library that you can use with Python and how you can use it. And then you can, of course, experiment with variations to perform other tasks.
Great, thanks. Next, we have, do you expect it will be possible to retrieve author affiliations for papers when querying the API, like API v1 research products that returns metadata about publications?
Okay, yeah, currently, as far as I know, the affiliation links that the OpenAIRE Graph includes are mainly links between organizations and papers. But I don't know if someone else from the Graph team, because there are, of course, some very recent work that is being done on the person side, the person entity, where in cases that we have ORCID information, we also have the connection between particular researchers and the research product. So I'm not sure about that. If someone from the graph team is present that can comment on that, maybe Miriam or Claudio, if they are here.
Good afternoon. I am Miriam. I am here. Can you ask the question again, please?
Yes.
Yes,
Sorry. So, do you expect it will be possible to retrieve author affiliations for papers when querying the API, like API v1 research products that research metadata, that returns metadata about publications?
It should be possible when the person entity will be delivered through the APIs. They will also have, when found in the data, the link to the organization they declare in the paper if we found the information. So for those that have ORCID, for which we are able to find a connection with an organization in the metadata of the results they authored, we will also have the affiliation, the declared affiliation for that paper. So yes, it will be possible.
Great, thank you so much. And then last, if we can wrap it up, we can answer all questions super quick. And apologies, of course, everyone, if you need to go. Thank you, first of all, for staying with us and for joining us here today. So last one, is it possible to do one search for a list consisting of, for example, several DOI numbers to find info about the corresponding papers? Or do I have to search for one DOI number at a time in a loop? And for reference, this one can be seen in the chat as well.
Yes, a good question that I don't remember by heart right now, but maybe Alexios can answer that. So Alexios, do you remember if in these endpoints we also support a list of identifiers?
Hi, I'm looking at it right now. Let me check quickly. So it's we are talking about research products, right?
Yes, or any other entity, but let's focus on them.
Okay, IDs, PIDs. Yes, it is an array, so we can in the request we can accept multiple IDs. So yes, it's possible.
Okay, thanks, Alexios, for that.
Okay, that answered. Great. So if there's nothing else, we'll wrap it up there. And as a reminder, we'll send, once we get everything uploaded to Zenodo and YouTube, we'll send you all the recording of the webinar and the slides to refer back to. And again, thank you everyone for joining us today. So let you get on with your days. And for many of you, maybe enjoy the upcoming long weekend. And thank you again, Thanasis. Thank you so much again for the presentation. All right, bye.
Thank you. Bye.